Hi, in the previous two videos we have seen how we can fine tune an instruction to train an LLM model and how we can prepare a dataset which can be directly fed into an LLM model for training. And now in this video we are going to see how we can actually train LLM model or fine tune LLM model based on the data that we have prepared. So using the Lamy API, so it can be also done in just 3 steps. We are just like loading our basic model, we are loading up our data set, and then we are just training it. So this is like how we can use some external libraries just to do all the things in just 3 lines. But let's take a deeper look into that, how it is actually being done internally. So first of all, we are importing some of the important libraries and packages, and then we have loaded our dataset which is in the form of JSON L file. And there are two ways to import dataset. Either we can use the Hugging Face dataset and provide the dataset name, and the other option is to directly use it from our internal file system and load it up. Then we are giving up the model name. So this is like one model with 70 million parameters, and then we are defining a training config in which we have to give the pre-trained model name. So this model which we have, it is already pre-trained, and now we are going to fine tune it, and this is the maximum length after which like it will be truncated. And then we are giving the dataset path. In this case, if Hugging Face is true, it will be using this dataset, otherwise it will be using it from our file system. After that, we have defined the tokenizer. So tokenizer we are taking from this model, and we have defined the padding token, and then we have splitted our dataset into training and testing dataset, and then we have printed that. So let's see how our training and testing dataset look like, how many number of rows are there. So we can see these are the columns in the dataset, and training dataset consists of 1260 rows and testing 140. Then we are taking the model. So this is the model name that we have mentioned above, and we are saving it into the base model. And then what we are doing, like if your system has a GPU, we are setting it to CUDA, otherwise it will be set to CPU. And then we are seeing how the base model which we have taken here, it looks like, what's the internal architecture and how many parameters it has. So this is the basic architecture of the model. Now comes the inference part. This we have seen in the previous video as well. So we take in the text, we take in the model tokenizer, maximum input tokens and output tokens. We tokenize the input text, we generate new tokenized output, we decode that tokenized output so that it can make sense to human. Then we strip the prompt which is appended, and then return the generated output. So now we are setting this text test data set. So this is the question, and we are printing the correct answer from the test data set, and then we are printing the model answer, what model is giving the answer. So this is the question: can Lamy generate technical documentation? So this is the sample answer which should be ideally predicted by the model. But in this case, we are seeing some garbage output which is not relevant to us because we have not fine-tuned the LLM model till now. So now we will train the model, we'll fine tune it. So we are setting the maximum steps to 3. We are then setting up the model name and the output directory where the model will be saved. And these are the training arguments. So we can see like number, learning rate, number of epochs. So we are just training it for one epoch and just for 3 steps. We are then setting up the batch size, output directory, and these are the other parameters which we can get into details, and we have like written the comments to understand it better. Then comes the FLOPS part, so floating point operations. So every GPU which you are or CPU you are training on, it has its own performance, like in how much time, how many operations it can do. So just to give an idea that how many floating point operation and what kind of memory footprint this model is going to have when we are going to train it. So this is the output. So it is going to take about 0.3 gigs of memory, and these are the floating point operations. So after we have set this training arguments and we are giving, now we are going to start the training process. So this is the trainer function in which we give the model name, we specify model floating point operation, total number of steps, training arguments which we have specified above, which consist of all the important part, number of epochs, learning rate and everything. And then comes the training and evaluation dataset, which we are setting it here. And then we have now started the training process. Since it is only done for 3 epochs, it has been done like really quickly, and then we are saving it into this directory. So basically this is the process where you like given the data set that you have prepared and you train your LLM model, and once the model training has been done, you can save it to a directory, and we are then using the same directory to get the model out. We are sending it to the GPU or CPU device based on your system, and then we are getting an output. So let's see now what kind of output we are getting. So first we are printing out the question, can Lamini generate technical documentation? Now this is the output of the fine-tuned model. I have a question, Lamini specific software develop. So we are seeing the output which we are getting now, it is not that bad compared to like non-fine-tuned model. So in the non-fine-tuned model we are getting output of this kind, but in the fine-tuned model the output is like little bit making sense now. So where were we? Yeah, so this was the output. It is little bit like making sense, and this was the actual output that we were expecting. It is not that great, but if you like train it for more epochs and more number of steps, this is definitely going to be improved. So just to see like if we like train it for like more epochs, how the output would look like. So we are loading up a pre-trained model again, and which is actually fine-tuned, and then we are like inferencing the output from this fine-tuned model. And now we can see how the output looks like. Yes, Lamini can generate technical document and all that, and now it is like very relevant and appropriate based on the actual target answer that we had. So basically if you increase number of epochs, number of steps, and fine tune it for like longer time, you will start getting the appropriate answers. There is also one more thing, we can fine tune our instructions in that way. For example, you started to ask model what do you think about mass, and which is not very relevant to the dataset which we have fine tuned on it. So this model can give you like relevant output. Let's keep the discussion relevant to Lamini. So we can also like give or prepare our dataset in a way so that our model can give output of this kind. Next come the evaluation part. So there is like another video in which we would be discussing about evaluation, but just to give like a sample of it. So we do like model evaluate, and it would calculate all the evaluation results of this model, and then there's a way to like stylize the output and see in like vertical tables how the predicted and the actual output looks like.